You wouldn't guess, but today we're going to talk about practical guide for Kubernetes deployment issues. So let's start with who we are. I'm Kit, and I need to find the way to switch slides. Yes, here we go. So I'm Kit. I'm a product manager at Octopus Deploy, and we also have
Liam, I'm a lead cloud engineer at Octopus Deploy. Yeah, we're both
for the
from modern
last
deployment team.
yes, and for the last few years, Liam and I have been working on everything related to Kubernetes, Kubernetes features, integrations, how to install Octopus on Kubernetes, and this year we've been working on the RVCD integration. But that's not what we're going to talk about right now. Today we're going to walk you through a real instant example, actual story, a battle story happened to Liam some time ago. We will use this example to show you how hard Kubernetes incidents might be. Not always, but sometime. We'll talk about the tools we used for the investigation of logics behind some decision made. Will you see some confusion that can actually happen between different people trying to see what's going on through their lens and their perspective? And finally, you'll see how the root cause was found and how essential the collaboration between different roles and different people involved in the incident was. This talk might be useful for, I think, everyone who wants to deploy to Kubernetes or run software on Kubernetes or just manage Kubernetes clusters, or everyone who just want to have fun listening to a real battle story. Okay, let's jump straight into that. We'll start this talk with just incident itself, what happened, how different people acted, and what they learned. Then we'll talk a bit more in depth about the framework. How would you approach this incident and how to build a better process? And we'll finish with Q&A if you have any questions in the chat. All right, so just a few words about Kubernetes deployments. Over the years, over the last few years, we talked to many customers, prospects and partners, and people doing develop different tools for Kubernetes. If we learned one thing from all those conversations, all those people, is that Kubernetes troubleshooting is not an easy challenge for everyone. Everyone struggles, everyone finds their own ways of doing things, everyone uses a bunch of tools. There is no golden or silver bullet, but I think we're getting there. Why is it so hard? So first of all, Kubernetes is absolutely a great tool. It's amazing in the way how it abstracts infrastructure from developers and makes life easy until the point that something breaks. And then this abstraction and this complexity might work actually against you. The thing is, symptoms you see, for example, as a developer, not always point to the root cause. You need to really dive deep into and compare different things to understand what's going on. Different roles could see different slices of the system. You don't have all the information. And well, the person who sees the issue first might just not be the person who can fix it or has anything to do with the problem at all. All right, so it's time to talk about our incident. Over to you, Lee.
Perfect. So today I'm demoting Kit from being the principal product manager of the team that I'm on to being a developer. You're down to my level now, Kit. So today I'll still be the infrastructure engineer, thank gosh. I'm the one that'll be owning the cluster. I monitor the platform, and I'm also the one that gets paged when things go wrong, which is a little bit frustrating. Whereas Kit, he's the developer. Now, he's going to be owning the application, he ships features, and he sees code, but not always the cluster. So the scenario here that we have is a Node.js-based GraphQL service. It's called the gateway, and essentially it's a mediator. It takes in GraphQL requests. GraphQL, for those who don't know, is just similar to a HTTP API, but more complicated, pretty much. That's all you really need to know about it. But you have this GraphQL mediator service, and it starts throwing DNS errors. We can see the error messages, and it's EAI again. Anybody who's seen that in production, number one, I'm sorry. Number two, in this case, is a temporary failure in name resolution. And then what we follow on from that is a day of investigation from two very different perspectives, mine and Kit's. So part 1, the infrastructure investigation. First, I get paged. In here, it says at 10:33 a.m., but that's only because I made a test page at 10:33 a.m. to do this. It was actually significantly earlier in real life, which was lovely. But in this, we're getting paged because we're seeing DNS failures in Kubernetes 01 prod. So, my first instinct, let's check the DNS infrastructure. Let's just have a look and see if we've got core DNS there. So I run kubectl get pods and just have a look at everything there. And core DNS there, everything's ready. Everything's fine. Ignore the restarts. That's just a bad screenshot that I took. Then I go through, run kubectl get logs, or kubectl logs. And I'm just going to have a look at just the latest logs because I expected there to be lots of logs. But core DNS and kubedns in general doesn't actually log out that much. It just says, oh, sweet, I'm running this configuration. I'm good to go. So everything's running, apparently. Well, yeah, everything does look fine. Maybe, just maybe, it's the networking. There are also meant to be emojis here, but it's stripped them out for some reason. So you'll get the idea. So the next thing that we do is we do a kubectl run, and this is just a debug DNS pod, right? So I'm going to go in and I'm just going to run ns lookup just off of some random pod. It's going to just double check that, we can see the accounts.production.svc.cluster.local. So that's just the accounts backend service in the production namespace. And still nothing. Everything's working. Maybe, just maybe, it's a capacity issue because DNS can act very different depending on whether you are running, lots and lots of DNS requests through it or very few. So I take a look at Grafana. Now, this dashboard is built in to the Kube Prometheus stack that you can get into your cluster. It's there by default. And if you install the Kube Prometheus stack, you get a whole bunch of information like this. And then you can just ship it off to whatever you're using OpenTelemetry data collectors with. So heavy recommend getting this installed into your cluster if you don't already have it. But I'll go back so you can see. But like in there, everything is looking normal. Our query rates, our latencies, everything, perfect. Everything is normal. So just as a little bit of a last hurrah, I scale the core DNS deployments. I'm just going to give it more. Maybe that'll fix it. Spoiler alert, it didn't fix it. It did not fix it at all. So every infrastructure check is coming back clean. Realistically, the DNS infrastructure is healthy, the network is working, and other pods seem to be resolving DNS without issue. So I throw it over the wall to Kit. Take it away.
Thanks, Liam. So imagine being a developer. This is like a beautiful morning, quiet, I'm working on my code, and then out of nowhere, interaction engineer knocks on my door. Almost never good news, and that's not how I want to start this day. But that's happening. So Liam comes and start with, hey, you know what? DNS is broken, and it's broken only for your app somehow. I'm pretty sure it's a software bug. Tell me, Liam. So what might mean, and from here on, it doesn't sound good, like at all. So my first reaction is I need to understand what happened with the what I deployed recently. If was it a new version or maybe something else. So conveniently, we'll look Octopus screenshots here as example. So I look into deployment timeline just to see what is actually going on and did I deploy a new version. And yes, I actually can see the change. So moreover, I know this change. I work on this. And this change was just to add a local cache for the backend server schema. The thing is, this actually has nothing to do with the DNS. So DNS shouldn't be affected like at all. So I need to dig a little bit deeper to just understand what I actually deployed and just check the manifest to see what changed in the version. Okay, what I see here is I didn't actually change much. The only thing I changed was the image, my contain image. So it shouldn't be a massive configuration change at all. So my next reaction is I need to go even deeper. So what I do, I'll open the pod logs. And yes, indeed, when I look at this one, I can see DNS errors happening in production. Okay, so definitely the thing is in production and it's not looking fun. But to confirm that it's actually my app, I want to look into test and dev environment. Because if the change happened for all of them, I should see the same issues there. Surprisingly, when I open my test environment logs, I didn't see any issues at all. So looks like test is absolutely happy, but production is definitely not. So how could that be happening? This is my next question. So what I'm doing from here is thinking about the difference. Okay, I have a lot of people working in my production environment, and obviously test and dev might not have that load. So what if the thing is just connected to how many people using the feature right now? Okay, easy. I need to verify that by replicating the load. What I'm doing from here, I'm opening my tools and starting to put many requests in my test environment. And then I just sit and wait. What should happen next is, well, the load goes up, and within the next few minutes, I'll see a bunch of DNS errors, wouldn't I? But unfortunately, I actually see nothing. What happens in reality 10 minutes later is, yep, my server slows down a little bit, but no errors at all. I don't see any issues. Nothing what I see in production. Even when I add 10 times more load than my actual production environment, I still see nothing happening. So this has started to become really concerning. And I'm starting to think about, okay, maybe after all that, it's actually an infrastructure issue. At this stage, we probably need to start working together. Obviously, myself or Liam, we just can't resolve the issue individually. We need to bring our heads together and start working on the problem. Okay, the first thing I have in mind is I go to Liam and ask and tell him that I can't find any issues in the code. And moreover, I can't replicate them in tests. So what do we do next?
I mean, that's true, but there's no other DNS failures in the cluster, and you've interrupted my lunch. Thanks a lot.
Well, the thing is, I know as a developer that the only change I made was to add cache, and that can't break DNS. But probably this is the time I actually tell Liam about it, about the change I made.
The cache, you said. Okay. Well, if we can't replicate the problem using the same code in test, let's have a look at the differences between test and prod. And this is also probably Kit's first time in hearing there's a difference between our test and prod environments as well, by the way. So in test, what we have is one replica of our pods and an SSD storage class, just because it's the default one there and we've only got one replica. But in production, we need to deal with a lot more traffic. We have 3 replicas, and we've got a shared storage class so that they can all use the same disk. This is interesting because is all of this really just to do with the shared disk? So I did some Googling. I actually think this is the exact same Google query that I used all the way back when this actually happened to me, which shows you what was going through my mind, where it's just DNS error, Node.js, Kubernetes, right? It's just shouting words at a void and trying to see what comes up. But I did find this really neat Medium article about how to fix Node.js DNS issues. And even in here, the author says that networking issues are the most challenging for them. And that is the same for everybody, especially when we're dealing with Node.js. Bingo. In the end, we tracked down what happened to a small bug. It's a little bit subtle until it hits you in the face like a brick. What was happening is the code that wrote the schema cache, when it wrote to the shared volume, it locked it to write. But when there were multiple pods and they were processing processing things for the same service, they would both attempt to write at the same time. Then other things would try to read and it would cause a deadlock. Bad things happened. And when the pods were contending to access that file, what was happening is there's a little thread pool in the back end of Node.js. It's called the UV thread pool. And it's by default has 4 threads. And those 4 threads are all Node.js has to work with asynchronous operations. So if a thread starts and tries to read a file and it's locked, that thread is now completely blocked until that file is able to be read. Now, unfortunately for us, in production, those 4 threads got completely blocked trying to look up that file. Something else that's asynchronous in this case, DNS lookup. Hooray! So our DNS lookups in production couldn't acquire a thread, and so DNS times out. Very, very lucky for me, at least as the infrastructure engineer, because this was a code problem. Except it kind of wasn't, because neither of us really had the full picture. I knew about all of the shared volume behavior, but only Kit knew about the new cache behavior, right? There was a little bit of a miscommunication here, or at least not a miscommunication. It's just I didn't know what the heck was going on in my own production environment. And Kit didn't know the differences between our testing environment and our production environment. So, as with all good incidents, I ended up running a retro on this to look back and then also to look forward. And what we ended up doing was changing our approach to failures quite a bit. Previously, what would happen is when an incident came up, engineers and specifically infrastructure engineers would take the call, they would have a look, they would investigate, and then if they found out it was a software problem, they would throw it over the wall to the developers, put it in their backlog, and that was that. But that wasn't going to work anymore. Not with Kubernetes, not with containerization. It's just too difficult. So what we ended up doing was 4 things. The first of which is involving developers early. These were the kinds of mantras that we were following from here on through, because we knew that developers had the most context. They knew the changes that were going in. And even if it is an infrastructure problem, it's usually going to be the intersection between an infrastructure problem and a software problem. And developers have that information. The next thing we thought we really needed was to make sure the deployment history was visible. As the infrastructure engineer, I didn't even bother looking at Octopus deploy. And that is if you're even using Octopus deploy. Getting a deployment history without a tool like this is actually surprisingly difficult, because you don't know if something's just deployed or what's changed and anything like that. So making it really easy for anyone to know what was deployed is super duper important. The other thing we tried to, well, maybe not force, but heavily encourage our developers to do was to document the dependencies. Nobody likes documentation, least of all me. But the seams between the hardware and software, like I said before, is where we see the most failures. So when software tries to access the network, or when software attempts to access the disk, these are the kinds of times where we need to be really careful and make sure that we're finding the right kind of amount of documentation to know when something is going wrong because of a change. You know, for example, this new change in caching behavior using the disk, or if it's something to do with the infrastructure that it's actually relying on. And then the last thing is you'll probably note that During this entire incident, nobody talked about just rolling back the code. And that's because at the time, it wasn't easy. There's a whole bunch of kind of like manual things that happened. We had to downgrade the database because we'd done a DB upgrade at the same time, a bunch of things. There were codependencies. It was really hard. And so from here on through, we weren't just automating our deployments, we were also automating our rollbacks. Because in the end, realistically, your customers don't care about how you fix a problem. They only care about how quickly you can mitigate it. Now, in real life, this was like a couple of weeks of investigation. We made it sound really easy in here, and it's really easy in retrospect. But hindsight is 2020, and it was not an easy problem to investigate. So if we had automated rollbacks, we'd be able to have a much easier time, I think, investigating and fixing this problem.
All right.
So yeah.
With that, thanks, Liam. That was exciting story, truly. And with that, we got to the end of our talk. So let's quickly recap what we learned from this incident and what could we change next time. So just two thoughts on this one. First of all, Kubernetes troubleshooting, Kubernetes issues, they span multiple layers, teams, and mental models. You can't just fight this battle on your own, and if you try, you will likely fail. If in your company, that's how we do stuff now in Octopus, you need to enable everyone to contribute their understanding of the system involved, of the code involved, on the actions they made to actually solve the issue together. You need to dive deep, you need to collaborate broadly, you need to solve problems with less stress, and as Liam said, ideally, automate. So, all those beautiful screenshots and thinking through and examples you can actually find in the blog post that Liam just posted yesterday evening. So amazing work, a lot of dedication to this one. So you can scan QR code and just follow the link, you'll find it there, and it's worth reading. You can also see all the tools to use in the process and all the just logical thinking through, so you can use this as a framework or just use a bunch of tools or just read it for fun. It's useful either way. We have a few more minutes, don't we, John? So if you have any questions in the chat, we can answer them, or we can just conclude this one a little bit earlier. Let's wait maybe 4 or 5 seconds.
I was going to propose that we take a look at this blog post that you wrote here, Liam. So this is, it works on my cluster. I love the name, A Tale of Two Troubleshooters. So basically everything that you saw in this presentation is being obviously expanded upon here. And if you want to have a look, you can go ahead and hit that URL and share it with your friends and get some feedback on it, which is great.
Cool. And just finally, Liam and I and all our team, we're actually really keen to hear your battle stories about Kubernetes, about deployments, about how you do stuff in your company. Maybe you find a way to visualize the issues better or trace them, or you use AI to help you resolve them faster now. So we'll learn from that, and we'll actually try to do our best to make our product better. So, or just have a conversation with you and share our insights. So if you want to share something with us and have a chat, we actually both are quite active in our Octopus community Slack. John, if you can just for a sec get back to our slides, I'll show the link there.
Oh, sorry.
That's another one. Yeah, so we have a community Slack. If you join it, you can DM me or Liam, or you can just join our Kubernetes channel there, and where we can have a bunch of discussions about troubleshooting, and not just that, just anything Kubernetes related. So please join and let's have a chat. Thank you.
Awesome. The other thing that I was going to mention, Liam, you were recently speaking at KubeCon. So you did a presentation on application performance with eBPF.
Yeah, absolutely. So that's actually recorded. Hooray. Yeah, you can see. No, oh god, I don't want to see my face. Please don't. Stop it.
Come on.
No,
It's fine. There you go. Look at that beautiful
there
man.
we go.
There you go.
Here I am. So over here I've gone through and done a quick talk about how mod deployments, kind of it does performance management for some of the components we're shipping into people's clusters. But being able to do that from from like the point of view that we're not going to be able to see the metrics inside of those clusters. So this is about the Kubernetes monitor and how we kind of traced performance bugs in it before we even hit them in production clusters and stuff like that. So if you want a little bit more of insight into how we run things at Octopus and how we use some cool technologies to solve some novel problems, that's a nice little talk for you to view.
Yeah, that's awesome. I find it kind of overwhelming at times to just kind of understand the entire ecosystem around Kubernetes. It seems like there's just more and more tools all the time. How do you guys keep up with all the ecosystem tools that are out there? Because I know it's a vast ecosystem.
I don't think you can. to be honest, I don't think you can keep up with the ecosystem. But what you can do is focus very heavily on the things that you need, right? It's not worth just adopting a tool for a tool's sake. You should adopt a tool when and if you have the need for it. And so I found that there are lots of novel use cases for these tools. You're like, oh my gosh, I'm having issues with like the speed that my images are being pulled to my Kubernetes cluster. So, oh, okay, maybe I can use Harbor or Firefly to go and investigate that. And yeah, there you go. Look at that CNCF landscape. It's a little bit busy there. Oh, look at that. Containerd's there. Woo. No, but realistically,
how do you keep up with all this? This is insane.
Yeah. Again, you don't. You just kind of choose the biggest box there. No, I'm kidding.
You're at stage 5 acceptance.
But heavy recommend having a look at that. What John was just showing, which is the CNCF landscape. That has quite a lot of tools in it, and they're all kind of separated by the use cases that they have. Very, very useful tool to just have a look. But,
do you find when debugging Kubernetes issues that it always just comes back to base primitives? Like you guys were talking in your scenario there, maybe it's just a networking. It seems like it's always DNS. Is it always DNS?
Not always, but more often than not. And even in this case, it wasn't DNS. It was the UV thread pool. Again, one of the few times it wasn't DNS. But a lot of the times, it does come back to primitives all in the end, whether it's, deep down at C groups, for example, having issues, or, a whole bunch of these other kinds of core bits of Linux that goes wrong. Everybody at Octopus knows me as the Kubernetes guy, but realistically, I actually started as just somebody who was really interested in the Linux kernel, and it just went from there. So
there you go. Awesome. I won't pretend to actually understand the landscape as well as you guys. I try my best, but there you go. Any other resources that you guys would like to cite before we wrap up here? No?
I just look at Octopus blog posts, actually.
Yeah.
I just want to say, look at Octopus blog posts. I think for the last few quarters, we published a bunch of things about Kubernetes, starting from how we work on features, how we just approach our investigation, and how we learn about problems, to very practical guides like what being posted yesterday. So there are a few golden nuggets.
Yeah, if you want to find out more about this, you can go on to the roadmap. Look at this; it's getting hammered right now. It's getting so slow. Everyone's looking at the roadmap right now. Lots of stuff that we're shipping around this. We talked about this during the obviously the release party kit, the granular permissions for deployments via the Kubernetes agent, support for RBAC, etc. I always come in here just to see if you guys have snuck something in here that you didn't tell anyone about, anything around Kubernetes on the planned list. But
we just actually added one yesterday. Now you see this new
tell
card
us.
for Argo CD. We just we shipped the brand new integration for Argo CD last month. I already have a few dozen people using it, although it's actually still early access and got released for self-hosted customers just last week, as we talked. And we just added a few things just to show what we're thinking about, how we're going to improve it next, what we're going to focus on within the next quarter or two. And just want to invite everyone who is interested or want to use Argo, thinking about using Argo, or use Argo and want to share how bad it is or how good it is, just go there, leave a comment, and let us know what else we can do better.